Hi dear students, welcome back to BS Academy. Today we are going to discuss the topic electric field due to system of charges. We have already know what is electric field and we have derived the equation for the electric field also. So now we are going to do the same, that is we are going to derive the same equation but for the system of charges. So see, for this you have to consider a system which is consisting of more number of charges. Okay, so for example you can consider the charge q1 which is placed over here, and charge q2 is placed over here, and charge q3 is placed over here, and charge q4 is here. So we are considering some 4 charges which is present over here. So this is what called as system of charges. So the system which is consisting of the 4 charges. So that is what we are discussing now, right? So now what will happen, students? For the charge q1, the electric field will be developed around the charge. Same way for the charge q2 also electric field will be developed. For q3 also electric field will be developed. Same way for q4 also electric field will be developed, right? So we have to find out the total electric field for the combination of these charges. So for that we consider a point P which is located over here, point P. So now our aim is to find out the amount of electric field at this particular point P due to the charge q1, q2, q3 and q4. Right, so totally depending upon these 4 charges, what will be the total amount of the electric field at this particular point P. So that is what we are going to derive. See, now the distance between the charge q1 at the point P to the point P is represented as R1P. Same way the distance between the charge q2 to the point P is represented as R2P. And for the charge q3 to the point P, the distance is represented as R3P. Same way for the charge q4 to the point P, the distance is represented as R4P. Okay, so now at the point P we are going to find the total amount of electric field due to these 4 charges. But we have already know what is the equation for the electric field. We have already derived, no? E is equals to q by 4 pi epsilon naught r square into r cap. So this is the equation which we have already derived in the last topic. Okay, so take this equation. Now for a single charge, this is the amount of the electric field. Okay, now we have to find out the total amount of electric field due to all these charges, no? So first of all we have to find out the electric field at the point P due to the charge q1. Same way electric field at the point P due to the charge q2. Same way electric field at the point P due to the charge q3 and also q4. So separately we have to find out the electric fields, and then we have to add all the electric fields so that you will get the total electric field at this particular point P due to all these charges. Okay, right. Now see, we will derive one by one. So now first E1, that is the electric field at the point P due to the charge q1 is represented as E1. So that can be written as, see, instead of q, capital Q, we can represent here as q1 because we are writing the equation for E1, no? This is the electric field at the point P due to the charge q1, right? So instead of capital Q, you can write it as q1. So q1 by 4 pi epsilon naught, then what is r? R is the distance between the charges, no? Distance between the charge. So here this r can be written as this r1p. Okay, r1p is the distance. So instead of r we can write it as r1p. So write it as r1p. So the equation will becomes r1p square. Same way r1p cap. Okay, so keep this equation as 1. Now same way find out the equation for the electric field at the point P due to the charge q2. So what will be the equation? q2 by 4 pi epsilon naught R2P. The distance is what? R2P. So R2P square into R2P cap. Keep this equation as 2. Same way E3. You can write the electric field for at the point P due to the charge Q3. So E3 is equals to Q3 by 4 pi epsilon naught R3P square into R3P cap. Consider this as the third equation. Same way E4, we can write the equation for E4. So this can be written as Q4 divided by 4 pi epsilon naught R4P. That is the distance for the charge Q4, no, that is R4P. So R4P square into R4P cap. So keep this equation as 4. Okay children, right. So now what we have to do, we have to find out the total electric field at the point P due to these 4 charges. Okay, right. So to find the total electric field, we have to add all these electric fields. So we will get the total electric field. Okay, right. So due to the superposition principle, we can write E is equals to, that is total electric field, E is equals to E1 plus E2 plus E3 plus E4. Okay, you can represent the vector symbol because it is a vector quantity, right. So here see, this is the total electric field. To find the total electric field, we are finding out the sum of all the electric fields. So this is superposition principle, right. So according to superposition principle, we can write E is equals to E1 vector plus E2 vector plus E3 vector plus E4 vector. Okay, right. For example, if you are considering the n number of charges, then you can write this same equation as E1 plus E2 plus E3 plus E4 etc. up to En. Now we are considering only 4 charges, no? So we are writing like this, E1 plus E2 plus E3 plus E4, right. So now see, you have to substitute all these equations, 1, 2, 3, 4, all these equations in this equation. So consider this as 5th equation. So substitute equation 1, 2, 3, 4 in 5. So what will be the equation now? See, capital E vector, that is total electric field, is E1. Substitute the equation for E1. So what is E1? Q1 by 4 pi epsilon naught R1P square into R1P cap plus what is E2? Q2 by 4 pi epsilon naught R2P square into R2P cap plus what is E3? Q3 by 4 pi epsilon naught R3P square into R3P cap plus what is E4? Q4 by 4 pi epsilon naught R4P square into R4P cap. Okay, so we have substituted all the values E1, E2, E3 and E4. Okay, now we have to simplify this. So we can take out the common terms. What are the common terms? 4 pi epsilon naught is the common term. So we can take it out. So taking out the common term, that is 1 by 4 pi epsilon naught. So what will be the remaining thing present inside the bracket? C, in the first term Q1 is there divided by R1P square. So R1P square into R1P cap plus in second term Q2 is there. So Q2 divided by R2P square into R2P cap plus in third term Q3 is there. So Q3 divided by R3P square into R3P cap plus in fourth term Q4 is there. So Q4 divided by R4P square into R4P cap. Okay children, is it clear?